Lesson 2, Rational Exponents. In this lesson, we're going to evaluate powers with what are called rational exponents. In Unit 3, Lesson 1, we learned about radicals and all of their properties. Recall an important property from that unit, that the nth root of x is equivalent to x to the exponent of 1 over n. To verify this for yourself, try it out with a simple number. For instance, the cube root of 27 is equivalent to 27 to the exponent of 1 over 3. Punch this in on your calculator, put brackets around the base of 27, and this should evaluate to give you 3. The reason is 3 times 3 times 3 is 27, so when you cubed root it, you're undoing that operation to get the number of 3. Let's practice with some more examples in example 1. These can be done on your calculator. Feel free to pause the video and click play when you're ready to resume. Okay, let's begin. First off, the fifth root of 32. This is equivalent to the base of 32 raised to the exponent of 1 over 5, and this will evaluate to give you 2. What this means is when you take 2 and raise it to the exponent 5, you get 32. In part B, we're taking the fifth root of 3,125. This is equivalent to the base of 3125 raised to the exponent of 1 over 5. Evaluating this on your calculator will give you 5. And finally, the cube root of 729. This is equivalent to the base of 729 raised to the exponent of 1 over 3. What we're really asking here is what number to the exponent 3 gives you 729. Cube rooting this base will give you the value of 7. Alright, so that was a review from Unit 3. Today's lesson is going to be a little bit more general for any rational exponent. Let's take a look. Numbers can be raised to rational exponents. These are just simply exponents that are fractions. The most general way of expressing a rational exponent is as follows. Let's take a look at the definition below. Here we have x to the exponent of m over n. M over n is the fraction that is the exponent, which is why we call it a rational exponent. Notice this can be expressed in two ways, so listen carefully here. You can take the nth root of x to the exponent m, shown over here, or equivalently, you can take the nth root of x and raise that to the exponent m. What we're showing here is the order of taking the root or raising the base to the exponent of m doesn't matter. And we'll verify this in the next example. But before moving on, what I'd like you to take away over here is when you're dealing with rational exponents, the number in the denominator, in this case it's n, that's always going to play the role of the root. For example, if that was a 2, it would be a square root. If it was a 3, it would be a cubed root. A 4, it would be a fourth root, etc. What I'd like you to also take away is that m, the numerator of the rational exponent, this plays the typical, for lack of a better word, I'll call it the exponent part. So for example, if m was a 2, you would square it. If it was a 3, you would cube it, etc. But we have to perform both of these operations when we're dealing with rational exponents. Let's take a look at example 2 where we'll see how this is done. We're asked to verify the above rule for 8 to the exponent of 2 over 3. I'm going to show you this both ways. Here we go. 8 to the exponent of 2 over 3 is equivalent to 8 to the exponent 2, all to the exponent of 1 over 3. So notice I'm doing the exponent part first and the root part after. So we evaluate this using BEDMAS. We'll do inside of the brackets first. 8 to the exponent 2 is 64. And now all of that is to the exponent of 1 over 3. And this is just like what we did in example 1 now. What number multiplied by itself 3 times gives you 64? Evaluating this on your calculator will give you 4. Let's try this again using the reverse order. 8 to the exponent of 2 over 3 is equivalent to 8 raised to the 1/3, in other words, the cubed root of 8, and all of that raised to the exponent 2. Notice I've just swapped the order. Now I'm doing the root part before the exponent part. 8 to the exponent of 1/3 is 2. That's because 2 times 2 times 2, 3 times is 8. And now we raise that to the exponent 2. Finally, 2 squared is 4. So I hope this example convinced you that the order that you do the root part or the exponent part doesn't matter. Both of them will lead to the same answer. Now a comment on negative radicals. Recall, the square root of a negative number does not have any real solutions. As you know, when you try to take the square root of a negative number, you get a calculator error. Let's generalize this though. Anytime you try to take an even root, and by an even root I just mean n, the index of the radical is even. So it could be a square root, a fourth root, a sixth root, etc. Anytime you attempt to take an even root of a negative number, that will not have any real solutions. However, odd roots of negative numbers are okay. So you can take, for example, the cubed root of a negative number. Let's take a look at this example. Notice that negative 2 raised to the exponent 3 is equivalent to negative 2 times negative 2 times negative 2, which evaluates to negative 8. Then, when you take the cubed root of negative 8, you're asking what number multiplied by itself 3 times is negative 8. This is in fact negative 2. So generally speaking, you can take odd roots of negative numbers, but not even roots. For example, if you attempted to take the fourth root of negative 16, try this on your calculator, see what you get. Recall this is equivalent to negative 16 to the exponent of 1 over 4. You're gonna find that you get a calculator error. So this would be undefined. Okay, moving on. The exponent laws learned in lesson 1 of this unit can be applied to rational exponents. Let's see how we do this in the next example. In example 3, we're asked to simplify each of the following and evaluate where possible. Let's get started. In part A, we have 25x squared all to the exponent of a half. Recall, you have to apply the exponent to everything inside of the bracket. So I'll write this out the long way. We apply the exponent of 1/2 to the 25, and we also have to apply it to the x squared. You can separate coefficients from powers like this. 25 to the exponent of a half is just the square root of 25, which is 5. And x squared to the exponent of a half, apply your power of a power rule here. To do that, you have to multiply the exponents, giving you x to the exponent of 1. We shouldn't write exponents of 1, so this will simplify just as 5x. Part B, we have a fraction, 16 over 81 y to the 8th raised to the exponent of negative 3 over 4. Because we have a negative exponent, I'm going to apply the reciprocal rule. So let's take the reciprocal of the base. And after doing that, our exponent becomes positive. Now, just to remind you, here we have a rational exponent. The 3 is the numerator. This is what I call the exponent part. And the 4 being the denominator, this is what I call the root part. As we saw on the previous page, the order that you do these operations in doesn't matter. So I'm going to do the root part first and then apply the exponent of 3. So this is equivalent to the 4th root of 81 y to the 8th all over 16. And now that is all raised to the exponent 3. To simplify this, we just have to take the 4th roots of everything underneath the radical. So what's the 4th root of 81? This can be done on your calculator. The 4th root of 81 will evaluate to give you 3. And the 4th root of 16 evaluates to give you 2. Now we have to take the 4th root of y to the 8th. As an aside over here, the 4th root of y to the 8th is equivalent to y to the 8th raised to the exponent of 1 over 4, which gives you y squared. And I'll write that down inside of the brackets. Okay, don't forget all of that has to still be raised to the exponent 3. And now we just simply apply the exponents. So 3 cubed is 27, 2 cubed is 8, and using our power of a power rule, y squared to the exponent 3 gives you y to the exponent 6. And that's going to be your simplified final answer. I'll put a box around that just to make it clear. Okay, moving on to part C. Notice that we're dividing two powers over here. Now, unfortunately, we can't divide them as is because according to BEDMAS, we have to do exponents before division. So let's begin by applying the exponent of 1 over 3 to everything in the brackets of the numerator, and then the exponent of 1 over 2 to everything in the brackets of the denominator. To begin, 27 to the exponent of 1 over 3 evaluates to 3. A to the exponent of negative 3 raised to the 1/3 gives you a to the exponent of negative 1. Just as an aside, what I'm doing over here, I'm multiplying the exponents. I'll show it here for the a. That's a to the negative 3rd raised to the 1 over 3. Just use your power of a power rule, and to do that, you multiply the exponents. In a similar way, we do the same thing for b. So b to the exponent 12 raised to the 3rd gives you b to the exponent 4. Now in the denominator, we're basically taking the square root of everything. The square root of 16 is 4. A to the negative 8 to the exponent of a half gives you a to the negative 4. It's just the power of a power rule again. And b to the exponent 12 raised to the exponent of a half gives you b to the exponent 6. And now we can divide using our exponent rules. So we have a coefficient of 3 over 4 that can't be reduced. Simplifying the a's, we keep the base and subtract the exponents, giving a to the positive 3, and similarly b to the exponent negative 2. That's a negative power, so I'm going to move that to the denominator beside the 4. Remember, all of this can be thought of as being over 1, and the 3, of course, is over 4. So, final simplified answer, 3a to the exponent 3, all over 4b to the exponent 2. And in part D, this one here, we have the 5th root of x to the 8th over the square root of x to the 3rd, all of that being to the exponent 3. There's a lot going on here. I think it's going to be easiest if we convert everything into a rational exponent. Let me show you how we do that. Inside of the brackets, I'm going to change the 5th root of x to the 8th as x to the exponent of 8 over 5. I'm just using the rule on the first page of this lesson in reverse. Similarly, the square root of x to the 3 can be written as x to the exponent of 3 over 2. All of that is to the exponent 3. All right, now that we've changed this into rational exponents, we can go ahead and apply the exponent laws. So inside of the bracket, you're dividing powers with the same base. You're allowed to then keep the base and subtract the exponents. So I'm going to do an aside over here. We'll keep the base of x and subtract our exponents. So that would be 8 over 5, take away 3 over 2. We can write this in terms of a common denominator as 16 over 10, take away 15 over 10, which simplifies to 1 over 10. Going back to the main problem now, inside of the brackets we have x to the exponent of 1 over 10, all raised to the exponent 3. And finally, we use our power of a power rule. We multiply the exponents to get x to the exponent of 3 over 10. That'll be your simplified final answer. All right, last but not least, example 4, simplify and evaluate where possible. This is very similar to part C of example 3. I'm going to begin by writing everything as a rational exponent. So in the numerator, we have 16 v to the 8 u squared, all raised to the exponent of a half. And in the denominator, we have 216 v to the 9 u to the 27, all raised to the 1/3. So let's square root everything in the numerator. That's going to give you 4 v to the exponent 4, u to the exponent 1. And in the denominator, we cube root everything. So the cubed root of 216 is 6. The cubed root of v to the 9 is v to the 3rd. And the cubed root of u to the 27 is u to the 9. I know this can seem a bit confusing, but we're just using the power of a power rule. In other words, multiplying the exponents. And now everyone, we just simplify. So 4 over 6 reduces to 2 over 3. V to the 4 over v to the 3 reduces to v to the exponent 1. And u to the 1 over u to the 9 reduces to u to the exponent of -8. We have a negative power, so we're going to use our reciprocal rule and bring that to the denominator beside the 3. Final simplified answer, 2v over 3u to the 8th. And that's going to wrap up lesson 2. Here's your recommended homework from the textbook. Try as much of it as you can. Thanks everyone. Take care. See you in the next one.